Am I audible? Okay. So I have just now I started recording through Zoom. So I will share with Nikita ma'am this thing. So let me start. Okay. Good evening. So today my yeah, I'm sorry. Yeah. Good evening. So today my presentation for faculty seminar will be on this topic, an object detection based solver for Google's image reCAPTCHA version 2. So actually I was reading this paper, so I thought of sharing this. So basically, the the recent version of CAPTCHA used by Google is reCAPTCHA version 2. There is also Google has also released another reCAPTCHA, that is reCAPTCHA version 3, but there is some security issues or basically privacy issues with the version 3. So the most commonly used one is reCAPTCHA version 2. But reCAPTCHA version 2, it has security leakages. That is, the reCAPTCHA version 2 can be what you call, it can be broken by deep learning networks. So there are many algorithms or many hackers who has already broken the basic version of reCAPTCHA version 2. So this reCAPTCHA is basically released by Google. So Google has made some considerable updates to its reCAPTCHA version 2, and it has made it more robust. Such a way that previously, whichever the algorithms which were able to break reCAPTCHA version 2, they are not able to break it. So Google has made some updates to the same version. Uh, but still, we cannot say that it is it is robust enough. So that is what this work argues. So as per this work, somebody has detected an object detection based system, and using that uh, they have even broken the updated version of reCAPTCHA version 2 of Google, right? And with this they are able to achieve a success rate of 83.25 percentage within a time period of 19 seconds. So this is the summary. So what they are doing, how the paper is implemented, that's what I'm going to share. So originally there is a reCAPTCHA version 2 that was broken by many algorithms. So Google has updated its reCAPTCHA version 2 by adding more features, but still it is not robust enough. Using some other techniques, this recently whatever the updates were added to reCAPTCHA version 2, even after adding the updates also, it is vulnerable. And and this work is actually an attack on reCAPTCHA version 2. And they were able to, so basically they are able to write a bot. So it's a software robot. They were able to write a bot, and this bot can break this reCAPTCHA. So the purpose of CAPTCHA is to not allow any automated program to access the particular website or the software. But that is getting defeated here. 83% of the time, these softwares were able to access these websites. Right. So this is just an introduction. So CAPTCHA is basically, it is a defense mechanism against malicious bot programs. So we don't want these malicious bot programs to access our website or software. So the idea of CAPTCHA, it is to make use of the unsolved AI problem. So CAPTCHA, so when the CAPTCHA will be strong, CAPTCHA will be strong if you use an uh, if it cannot be solved by an AI problem. So CAPTCHA should use such things that currently we should not have any AI algorithm to solve that, but it should be easily solvable by human. So there are two things. We should not have any AI program to solve the CAPTCHA, but at the same time, it should be easily solvable by human. That doesn't mean that we can give a complex mathematical problem, because AI can solve, but the point is it should not be solvable by AI, and at the same time it should be easily solvable by human. So that should be the, what you call, the feature of the right CAPTCHA. So for the past 2 decades, due to the improvement in AI, machine learning, and deep learning, CAPTCHA is becoming more vulnerable. They are under attack, and Google has withdrawn its first version of CAPTCHA, the RECAPTCHA version 1. Basically, it's a text CAPTCHA, and Google is no more using the text CAPTCHA. Google is using only image CAPTCHA. So image CAPTCHA is considered to be more superior and secure. So the image CAPTCHA version 2 was released in 2014. So version 2 itself is image CAPTCHA. Version 1 is text CAPTCHA. But it was found that deep neural networks can successfully attack this CAPTCHA. So Google has made several security updates to this reCAPTCHA version 2. So what are the updates Google has done? So basically these are the updates Google has done. So now the images that Google is using for reCAPTCHA, they were collected from a complex and a common sense based domain, as opposed to monotonic simple images. Previously, the version 2 of CAPTCHA, it is using simple monotonic images, but now they were using more complex images. That doesn't mean that it is not understandable by humans. It should be understandable, so that it should make sense to a normal ordinary human. So it should be complex. At the same time, it should be recognizable when you use common sense. And also they are adding noise to these images. They are making it blur, and they are doing some distortion to the images, so that any bots, normally if you write a deep neural network program, we don't train the neural network with noisy images. We provide with good images, and then only we'll train. So they provide noisy images and blurry images, so that if any programs try to defeat the system, they should not be able to defeat it. So with that intention. And also they include some images which were created by using adversarial so basically GAN, generative adversarial networks. So using generative adversarial networks, images can be created which don't really exist. So such images also they were adding here. And if Google suspects that somebody is suspicious, then they increase the difficulty level of the image that is being provided. Apart from that, Google also is using some anti-bot detection mechanism, which detects web automation techniques, like whether a program using Selenium is trying to access this CAPTCHA or not. Like that, it checks, because Selenium is one of the commonly used tool to to attack the CAPTCHA system. So Google also uses this anti-bot detection system to identify is any tool like Selenium is being used. And also this version 2, Google has added two types of CAPTCHA. One is called as click-based CAPTCHA, and the other one is called as just it is select CAPTCHA. So there are two types of CAPTCHA. One is select-based, and the other one is click-based. So these two CAPTCHA Google has added. So we'll discuss what is the difference in the later slides. Okay. So how CAPTCHA works basically? So basically, there will be a checkbox, something like this. There, it will be written like this: I am not a robot. So when you click on this, I am not a robot, sometimes Google will not provide any CAPTCHA at all. It will allow you to enter to the website. If Google feels that nothing suspicious is going on. But if Google senses that something suspicious is going on, then the Google will provide the CAPTCHA image. Then the Google will provide the CAPTCHA image, and we have to solve the CAPTCHA. So basically, CAPTCHA is a challenge. So CAPTCHA 2 is an image-based challenge. So once you solve that challenge, you will be allowed to access the system. So as we already mentioned, Google has released even the reCAPTCHA version 3 in 2018. It is called as frictionless CAPTCHA. The version 3 is called as frictionless CAPTCHA because there is no interaction from users is required. That is, we need not select any image or anything as such. So even we don't know there a CAPTCHA exists, but Google know without our knowledge it collects some information from us, and then it identifies whether it is a human or a bot. So because of that, it is considered to be having some privacy issues. So there are some legal issues with it with this reCAPTCHA version 3. So it is not so popular as of now. So okay, so this is a typical CAPTCHA looks like. So the image CAPTCHA. So the image CAPTCHA can be divided into 3 parts. So this top part, the top part, basically this contains the text. This contains the text like what is to be selected. And this top part normally contains 2 lines. The first line and the second line. The second line actually it includes the text which is to be the image which is to be identified, and that image will be represented in text format. And this is the second part which contains the actual images. Basically, these images are embedded within a HTML using the table tag. So they are embedded using table tag. So this is a row. So this is a row, and all these are different columns. So in different columns, they'll use different images. But in most of the cases, Google is using the same image. Actually, if you see, this is one image only. This one image is only being used by all these columns. Okay, so most cases Google is using only a single image, and this is the third part which contains some button or to change the CAPTCHA or to skip all those things. So this is how the structure of the CAPTCHA. Because this paper is about how to write a bot to fool the CAPTCHA system through a program rather than by a human. So we need to know all these things, right? So this entire thing is called as the challenge widget. So this is what I have just showed. It has 3 sections: top section, and the middle section which contains all the images, and the bottom section which contains some buttons. And these images are present within the HTML tag, and they are placed within the rows and the column tag, and each cell will have an image tag. Using this image tag, if by accessing this image tag, we can get the image. So the actual image we can access by accessing this image tag. So inside the table tag, there will be tr, the row tag, and inside that there will be the td, I guess. So using this, in this td, there will be image tag. So from this image, from this source, we can get the actual image. So once we get the actual image, then we can apply some object detection technique, and we can check whether a particular object exists or not, so on and so forth. So most of the cases, Google uses single source. It uses a single image for all the columns, and the single image is split across multiple table cells in equal proportion. So this is the so this is how the widget is divided. So the number of rows and number of columns or depends, it may vary, but we can count how many rows or how many columns are there. That also we can count by counting the number of tr. So if you count the how many tr tags are there, so tr represent the row. So by this we can count the number of rows, and inside that how many td are there. With that we can identify the number of columns. So the number of columns in each row will be same, so that will not be an disproportional distribution. So if first row contains 4 columns, then all rows will have 4 columns. So with this we can identify like how many rows and how many columns are there. So so Google is now using 2 types of CAPTCHA. One is called a selection based image CAPTCHA. The other one is called a click based image CAPTCHA. In case of selection based image CAPTCHA, we have to just select these images. We have to identify some object, maybe bus or whatever it may be, the bus or car or this what you call parking something, right? So we have to just select 1 2 3, select and click on verify. So that type of CAPTCHA is called as select based CAPTCHA. But there is second category which is called as click based CAPTCHA. In case of click based CAPTCHA, what happens when we click on one object, that object will disappear. This will disappear. Some other object may come here. Now again we have to click. So we have to keep clicking until that particular object disappears. So if it is bus, when you click on, if a bus is here, if you click on here, the bus may disappear here and it may come somewhere else. So then we have to click there also. So we have to keep clicking until there are no buses here. So such type of CAPTCHA is called as click based CAPTCHA. So here this attack is basically consists of two modules. One is called as browser automation module. The other one is the solver module. This browser automation module, it takes care of all the web related things. How to fetch the CAPTCHA image, how to, first of all, how to, so this includes information like how to identify the object to be detected, which object to be detected, how to identify that, and how to fetch the image, from which image we have to check whether the object is there or not. After detecting the object, how to ensure that those objects were selected, and we are clicking on the verify button. So all these things human is not doing, now this program is doing. So these parts will be taken care by this browser automation module, and the solver module will do the actual object detection. So it uses some existing object detection tools to perform the object detection. So these are the activities or the functions which is done by the browser automation module. It locates the reCAPTCHA checkbox. So first there is a checkbox like I'm not robot. So that checkbox it first locates where it is, and then it identifies the potential HTML elements on the challenge widget, like what is, where is TR, where is TD, all those things it will identify, and within TD surely the image tag will be there. So from the image tag it will fetch the image. Then so it is up to fetching only. After fetching the image, this information it will give to the solver module. Now the solver module will identify what type of object it contains and it will return some results. After getting the result will be submitted to the CAPTCHA. Again, for submitting also those things should be selected. So basically in the CAPTCHA, how it is implemented means all these are buttons. Actually everything is a kind of a button. On the button the image is placed, so that we are able to click all those things. So basically these are buttons only. So in this button you can enable the click. So you can using the code you can make as if the click is on. So that's what it does. And then it monitors the progress of the challenge, because if it is a click based challenge, then some images will change, then accordingly this entire thing should be looped. And finally it checks the verification status, whether it is whether the bot is able to successfully enter into the website or not. And solver module, it contains two parts. One is the object detector module, the base object detector module, and the other one is a module which maps the bounding box with the mapping algorithm to the grid mapping algorithm. Because the grid, in the sense we are calling the grid in the website part. The website part, the CAPTCHA is given within the grid, so that is called as grid. But in the actual image there may be different images. There may be a bus, there may be a car, there may be the parking meter, so many things. So but we may be asked to find car. So if car is located here, then here in this website it is available at which grid. So that mapping, so from image to this mapping should be done. So that will be done by this module, bounding box to grid mapping algorithm. So this module will take care of that. So these are the activities of the solver module. It fetches the image and then it identifies and localizes the object. It returns its class name and the confidence score. So it may find different object with the confidence score it will return. And also it will return the coordinate information, that is the bounding box details. What is the two corners, the XY details it will specify. and it should also map that with the whatever in the website part. So yes. So how the browser automation module works? So first thing the browser automation module should do is it should identify this particular checkbox, the checkbox which contains "I'm not a robot." So how it will identify, in the sense it will look for this element, reCAPTCHA anchor. So this element will hold this checkbox. So that is how Google programs. So it looks for this element. So sometimes its name may vary. For example, here it is in this code, it is G hyphen reCAPTCHA. So basically, this is the one which creates that checkbox. So it identifies that, and it will make sure that that checkbox is enabled. Okay. So this is the code for enabling the checkbox. Driver dot find element by CSS selector reCAPTCHA dot checkbox hyphen checkmark click. So this will automatically click that checkbox without the presence of a human, right? And extracting the challenge instruction. So in the what you call in the CAPTCHA, as you know, the CAPTCHA is divided into three parts. This is the middle part. At the top part, the challenge instruction will be there, and at the bottom, some buttons will be there. So this challenge instruction is available here. How to extract the challenge instruction? The challenge instruction only contains the object to be detected. So again, that can be identified by using this element, RC hyphen image select instructions. So Google places the challenge instruction within this element. So here is the partial code is shown. So this so the our program should look for this element. So if you look for this element, then here whatever the text is there, we have to take that text, and that text will contain the information like which object is to be detected. And then downloading the challenge image. So downloading the challenge image, that will be available within this element, RC image title. So the program should look for this particular element, RC image title. Here whatever the SRC contains, so that is actually the image. So if we download this image, so that is done. So now we got the image, and also we got the name of the object to be detected. Now we apply some object detection technique, and we detect whether the image where the object is located. Once we identified the object, then we should map the bounding box details with the grid detail. Once that mapping is done, we have to finally click on the verify button. At last, after selecting, there is a verify button. We have to click on the verify. So how we are going to click on the verify button? For that, we have to look for this particular element, reCAPTCHA verify button. So that button, so that is basically a button. It's just a HTML button. So we have to enable that button. That's it. So the object detector that is being used here is it is YOLO v3. So there are many object detectors available, but this paper they were using YOLO v3 because of its speed. It may not be detecting, so we cannot say that it is superior in detection. So there are some algorithms which does even better than that, but with respect to speed, it is superior. And the data sets used is this MS COCO data set. It contains 8,000 training images and 40,000 validation images with 80 object classes, out of which 8 classes were frequently appear in CAPTCHA challenges, which were used by Google. Apart from this, it also uses 6,000 images custom data sets. So the data sets created by the author of this paper with 2,100 images from reCAPTCHA. This 2,000 out of the 6,000, 2,100 images or images which appear in reCAPTCHA, which includes 11 objects. So these are the 11 objects this data set contains. And they were trained using YOLO v3 with a batch size of 64 with a learning rate of 0.001. And finally, it will provide the bounding box, and this bounding box should be mapped with the potential grid numbers. So grid, whenever we say grid, we are referring to this website part. Okay, so it should be mapped to the grid number. So this is, for example, if this is grid 1, 2, 3, 4, 5, 6, like that, it is numbered. So which grid number that object is available, like that it should map. And that detail will be returned as a JSON array. So it is something like this, it returns. So if this is the image, so here object name is bus, confidence score is 99. This PGN represents potential grid number. Potential grid number is 0. So it is highly likely that there is a bus in this grid. And object name bus, potential grid number is 3. Confidence score is 53. So here bus is in the background. It is not in the front. In the front, some other object is there. So its confidence score is somewhat less, but it's correct identification. Okay, and also here bus confidence score 27, PG potential grid number 2. So it is something blurred. The image is very much blurred. So it's giving like this. So it gives the potential grid number. So with this, that particular grid is nothing but a button. So that button will be activated or enabled. And based on this JSON array, the browser automation module will extract and it will enable the potential grid numbers, and also it will verify it will also click on the verify button, right? Finally, we should know whether it is successful or not. So how to know whether it is successful or not? Again, there is an element called GRECAPTCHA response. Initially, this element will be empty. Before clicking on verify, this will be empty. Once we click on verify, and if the challenge is successfully solved, then this element will be populated with a long string. So after clicking on verify, we should check whether this element contains some string or not. If it contains some string, then it means that we have successfully solved the challenge. Otherwise, even after clicking on verification, if it is empty, then it means that our algorithm has not solved this particular challenge. That's what it means. So this particular algorithm, they have tested with 800 challenges on 4 different websites. Out of that, 701 challenges were based on selection-based CAPTCHA, 87 challenges were based on click-based CAPTCHA, and 12 were the CAPTCHA was not opened in 12 cases. That is, initially when you click on I am not a robot, the website has just allowed to enter. It has not displayed any CAPTCHA. So that were the 12 cases. So out of this, the software or the program was able to break 656 challenges with a success rate of this much percentage. So it was also tried with other image recognition techniques like Google Cloud, Microsoft Azure, Amazon, and Clarify, but the success rates are very low: 19, 34, 47, and 27. So this particular graph, it shows like in case of selection-based CAPTCHA, which type of images occurred more frequently, and what is their success rate. So from this we can see this traffic light, crosswalk, car, bus. These are the things which appears commonly. So we can also know from our experience. And this shows for a click-based CAPTCHA. For a click-based CAPTCHA, so these are the things frequently appear: fire hydrant, crosswalk, car, bus, or bicycle. And this represents the success rate. And these are the frequency of different objects that appear in all challenges. So that's it. So to conclude, actually, so currently Google uses ReCAPTCHA version 2 with some updates, but still we cannot say that ReCAPTCHA version 2 is robust enough because we have strong object detection tools, and those object detection tools are they have already outperformed human performance. So no more CAPTCHA can be considered as a safety tool, or Google should think of some other different way of providing safety to the websites from software bots. So actually this I'm present. This is not my work. So this is based on this paper. I just read this paper, so I thought of sharing this with you. So that's it from my side. Any questions? Thank you, ma'am. Tell me, sir. Yes, sir.
Actually, you have mentioned 84% initially. That is about what, sir? Like breaking this CAPTCHA system.
Yes, sir. They 801 cases they tried, sir. They were able to successful in around 750 or something. So that.
Yes, sir. At the end, you have shown 90%, 27% like that.
90%. Where, sir? 19. So this is with some other. So actually, the author of the paper is using YOLO for object detection. Instead of YOLO, if they use Google Cloud Vision, the success rate is 19%. If they use Microsoft Azure, the success is 34%. So they are saying that YOLO is better. Yes, sir. All these are image recognition techniques. Yeah.
Okay. And 84%. Why that is performing that much? Sir, 84 is incomparable. Are there any other?
Sir, they have also specifically trained on YOLO only. This author, no, they have trained YOLO for that. These things they might not have trained directly. They might have used. They have taken YOLO, but they have also trained YOLO with their data set. But this comparison, I think they have not trained specifically. Yes.
Sir, any other scope in working for that?
Sir, I'm interested, but we need this NVIDIA systems, no, sir. They are in this paper. They are telling that they trained for 15 days. This data set for training they took 15 days. Yeah, and some good students also recruit, sir. With we alone, I don't know how. Yeah. Yes, sir. Thank you, sir. Mr. Madhu, any questions?
No questions.
Okay, thank you.